This session is about change and disruption from a neurobiological perspective. Neuroscience is really interesting because a lot of people, when they see fMRT scans, they attribute a lot of credibility to it. There's one quote from Joost Langdata, a famous philosopher, who said, if the brain was so simple that we could fully understand it, we would be too stupid to understand it. Meaning, we are in terms of our maturity of understanding the brain, we are probably like the human beings at the time of the Renaissance, looking through binoculars to the stars, trying to understand solar systems and making conclusions about is the Earth flat or is it round. So we are at the beginning of a process. And so we need to not forget, we must not forget to apply common sense in all we do with findings from neuroscience, because they are so tempting and they are so credible, and that makes it even more important to be very prudent. So I've been to a Change Congress, Handelsblatt Change Congress in Düsseldorf, and what struck me there, people were standing on stage and were talking about change, and they were talking about, there's these people that don't want to change, and there's this change resistance, and so change resistance is kind of bad, right? So there's change is good, change resistance is bad, and I found it a little bit oversimplistic. So actio equals reactio, that's one of the Newton's hypothesis, meaning if you have a force that forces in one particular direction, like change, there's a natural force against it, a counter force. That is a natural law. However, if we think of change disruption, that would be the force, right? So we are actually hoping for acceptance and learning. That's, according to the laws of physics, doesn't really seem to jive. We are not made that way. What happens instead is that we get denial, we get confusion, we get victim mode, and we get stress. Change resistance or change, very often, if you look at organizations, what I see is being spoken about on three different levels. Predominantly, it's on economical levels. We need to change because our market position is threatened. We have competitors coming from the outside. Our EBIT is below 7%, and we need to be amongst the first two in the market, in the ecosystem, in order to play. That's a purely economical reason, and for that reason, we need to let go of 4,000 people, right? It's absolutely logical. Makes absolute sense. Unfortunately, the 4,000 people don't really feel that this is a good reason for them to be let go, right? So there's another level, obviously, which is a psychological level, meaning, that affects me, and as a human being, it does something to me, right? And then there's yet another level, which is the neurobiological level. And neurobiology is one other channel to explain psychological phenomena. It's just another way of explaining it. If we look at the evolution of the brain, we need to look at that real quick in order to understand why our brain has an energy crisis and how the brain has solved the energy crisis. These are the findings of humans and human ancestors starting going back to 7 million years. And what you see on the other axis is the weight of the brain. Okay? So our skull has been growing over the millions of years. But what is very interesting is it has been growing not very much for about 6 million years. And it has been growing like hell for a bit less than 1 million years. And the question is, why is that? There's different theories. Again, I'm not telling you the truth because nobody was there. There's different hypotheses. Some say, well, because we need to learn to speak. And in order to learn to speak, you need different areas in your brain to be developed. Others say, well, actually, we needed to learn to live together. And in order to live together, you need to have different areas of your brain in order to be able to do that, to form a social system. And there's a very simple theory that makes a lot of sense to me. And this is, in order to grow, the brain needed sufficient nutrition. It is around that period of time, 1.5 million years roughly, that humans started to master fire. Fire meaning I get fire when I need fire, not when there's lightning and my house is burning down, or my hut, right? So, and that made cooking possible. Now, cooking is, if you look at it, is a form of pre-digestion. If you cook, you pre-digest, you make it easier for the body to digest, you make it easier for the body to take in calories. And the brain is a very hungry organ and needs a lot of calories, especially a brain with a cortex. So cortex is the outer part of the brain with the more modern functions like planful thinking and acting. And this part of the brain, and different mammals have different types of cortex, these cortex needs especially a lot of amount of energy. And the question is, where do you get this energy from? So, fire cooking was important. Then the next thing that came up afterwards was development of language. Then the first settlements occurred. So people kind of settled down, they formed tribes, they built shelter, houses, huts, whatever. And also that develops the need to, how do you organize a social system? And one thing that is very, very important when you organize a social system is you need to have a rank order. So when two human beings meet for the first time, which part of the brain is activated at first? So the first thing that gets activated is actually the area that is in charge of processing numbers. So why would you, when you meet a person for the first time, activate the portion of the brain that is in charge of processing numbers? Why on earth? You don't want to calculate the value of the jacket or whatever? Because, well, again, it's a hypothesis, because you are kind of leveling out where in the hierarchy am I compared to this person. That led to the situation where the human does not have the biggest brain on earth. The brain of the blue whale is much bigger, but it is the brain with the biggest cortex on earth. So the biggest capability to develop planful ideas, be creative, come up with own plans, own models of the world. So, and that also leads us to the energy crisis, because as I said, the brain is a very hungry organ and it needs to be fed. So let's look at this energy crisis. So the brain is 1.5, 1.6 kilograms, and for the most, or for the ideal person, not for me unfortunately, but for the most person, that's 2% of their body mass. But this 2%, how much percent of the energy consumption is due to the brain? When you're sitting here and listening, we agree that you're not moving your muscles much, right? You're sedentary, you're looking at me, you're obviously listening attentively, you're digesting if you had lunch. If not, you manage your hunger. So how much of your energy consumption is due to your brain? So 25% is used by 2% of the body mass, even though we are digesting or doing other things. It is a difference if we're using the neocortex to think, or if we're using the older structures of our brains to think, and the reason, or the difference is the amount of energy consumed. That means that overusing the cortex for us is exhausting. Actually, what happens is, due to the fact that we have a conscious brain, which is the neocortex, I'm oversimplifying dramatically, and there is a more unconscious part of the brain. That will be the mammal brain, the amygdala, the pain system, the reward system, all these kinds of things. The unconscious, the non-conscious, controls actually what we are doing. So think of the following scenario. You're driving on the Autobahn, and despite the rules and regulations, you're having a call. Obviously, you have a headset, and you're all legal, both hands on the wheel, but you're having an interesting conversation, and traffic is running smoothly, and after 10 minutes of an interesting conversation, do you know exactly what you've been driving through? No, you don't, right? Because somehow the unconscious part took control, and our body knows exactly what we're doing, so you're steering. But what happens when a lorry pulls out 10 meters before you, in front of you? All of a sudden, adrenaline gets evoked, we get awake, we stop the conversation, and we focus on the situation. So there's kind of a remote control, and that remote control switches our brain from unconscious mode to conscious mode. It kind of shifts where our conscious attention is being focused on. This means we have two areas. One is the prefrontal cortex, high energy consumption, used for planful thinking and planning and acting. And on the other hand side, we have the limbic lobe. The limbic lobe, lower energy consumption, used for feeling, for emotions, and for subconscious processes. There's a couple of things that we can learn from that if we look a bit deeper. So one of the reasons, or I would talk about the neurobiological drivers of humans. One of the most fundamental reasons or needs is for us to belong. We need to belong to a group. And why is this? And we look at the 7 million years of our evolution. For the majority of this time, we were food. We were not top of the food chain. We were the food. We were sharing the environment with predators that would like nothing more than to have us for supper, right? So as a result, there's the one thing that a human must avoid at all costs, and that is being expelled from a group. Because if you're expelled, you're basically food. You're doomed, right? So saber-toothed tiger, all these funny creatures, and they all like us. And there's another thing. I'm going from neurobiology to psychology. There's another theory here that because of that, we as humans, and I would tend to say as Germans predominantly, have developed something that's called a negativity bias, meaning I have a special scanner for everything that is going wrong that could eventually lead to a situation where I get expelled from a group because somebody doesn't like me. Other thing, why we need to develop. So if we look at our evolution again, 70% of our brain development happened in the last million years, which is by evolutionary standards quite fast. That also led to a situation where humans is the only mammal species that is built or that is born with a brain that is absolutely not ready. If we would not take care of our kids for years, many, many years, they would all die. This is because the brain, the human brain, in contrast to many, many other brains, is a so-called open system, meaning it has a lot of stuff basically created, but then it needs to be formed and shaped by using it to form out stable neural networks that are then the equivalent of knowledge. What's the basic kind of interest of the brain? So the brain strives for something that we call equilibrium. Equilibrium is a healthy mix of neurotransmitter, healthy concentration levels of neurotransmitters, and there are two different centers in the brain that play an important role there. So the first structure that is of high importance is the so-called insula. So the insula, amongst many, many other parts of our brain, plays a role in our so-called pain center. The interesting thing with pain is it is the same pain center that gets activated when we take a hammer and hit our thumb. It is the same pain center when we get not asked to join for lunch. Very same thing, right? What happens when the pain, and by the way, it's also the same pain center when we get fired, to refer to the first example. So what happens? Neurobiological stress, meaning adrenaline, noradrenaline, and then we have all chemical processes, eventually this cortisol that we have in our body. As a result, all the higher brain function, cortex, neocortex, they get inhibited, meaning activity gets reduced, meaning planful thinking and acting gets reduced. And instincts, now we're on the amygdala, we are on the more mammal side of the brain, instincts like flight, fight, or freeze gets activated. On the other hand side, there's a center that is called the reward center, and Professor Elgar, as I said, when he's treating epilepsy, what he was able to do with mice is that he put electrodes into their brain. So it's a pretty cruel experiment, I have to say, but he put electrodes into the mice of the brain, and he would stimulate this reward center, and he would give the mice a buzzer. So they could press on the buzzer, and their reward center got activated. And what happened as a result? They did nothing else. They forgot to drink, they forgot to eat, they forgot to have sex. They were just interested in this buzzer, because this is the strongest thing that we have in our brain. An energy that we hardly ever really realize, but it's like total happiness. Now what that does is, once this is activated, neurobiological well-being kicks in. Higher brain functions like the neocortex get activated, and as a result, we become better than we actually are. We become more creative, sharp, crystal clear, focused. We can focus all our energy on one point. And these are the two basic ideas. Our brain, as I said, is a prediction machine. So it tries to predict the outer reality. And it does that based on our model of the world. That is a very powerful example of how our model of the world forms our perception of the world, and hence it forms our reality. Now let's think, our brain centers get activated, and we know this phenomena. That means that our model of the world actually changes. We see different things. Not only do we see things differently, we see different things. We see everything that is going wrong. We see everything where I can't do something. We see everything where I feel helpless. It is not only that we feel it, our reality changes. And the interesting thing is, in this neocortex, one area is the visual cortex, and only a thrilling number of 17%, this is less than 20%, of the neurons in the visual cortex are actually linked to the outside world. That tells us that systemic theory, Gestalt theory, systemic constructivism, Macy conferences, even though they didn't have MRT, were actually right. It is the neuroscientific proof that we construct our reality, which is what I mean when I say you can explain it psychologically and you can explain it on a neurobiological level. Okay, so one step further. So the brain likes congruence, meaning it wants to avoid pain and it strives for well-being. How does that translate into neurobiological needs? I developed a model that is called the six basic neurobiological needs of humans when being in a system. So first thing is, try to get well-being, avoid pain. Now, as I said, from our evolution, the most basic need that we have is to belong, right? So the first one is sense of belonging. Now, the second one that I said was we also need to grow, right? Our brain is an open system, and it only works when we actually grow. So we have two opposites, so we actually have a dichotomy. Because, who of you has kids? Who of you has kids in puberty? Okay, if you have a kid in puberty, you are experiencing a life experiment of a fight of sense of belonging and growth at the same time, right? Because at the one hand side, they want to hug, well, only if nobody else sees them. They want to belong, they want to feel love, but then they also say, no, I can do this myself, I can take my own decisions, right? I mean, I have 4 of them, and you can actually really experience that. So it's a struggle between sense of belonging on the one hand side and growth on the other hand side. The next one is orientation and control, and on the other hand side, autonomy and self-efficacy. Self-efficacy? Selbstwirksamkeit, yeah? So being the master of your own destiny. So why is this a dichotomy? So assuming you have a boss who gives you orientation and control, meaning, okay, you need to do this in that way. You do A, B, C, and when you do this, you sit like that, then you get all the kind of orientation and control. You know exactly what's expected of you. What does it do to autonomy and self-efficacy? Yeah, it kind of suffers, right? Because I feel like a robot, right? On the other hand side, when you get sent to China, good luck, this is your task, we don't know anything, it's for you to sort out. You have a lot of autonomy and self-efficacy, but you're stressed out like hell because orientation and control is gone. Self-worth and status. So as humans, as I said, the status is very important because from an evolutionary perspective, we needed to fit into a peer group somehow. On any level, but we needed to fit. Hence, our understanding of status is very important. We need to make sure that we belong somewhere, and hence we need to be careful of where we are, where we fit in. But on the other hand, even babies have a built-in sense of, is something fair or appropriate? What do we learn from this? Optimal conditions for brain is a congruence between those 3 dichotomies. So how do we actually learn? So now we have understood why we need to belong. We have understood the basic wiring of the brain, the conscious, the unconscious. Now let's assume we have gone through this valley of tears how do we actually learn? Because change and disruption has to do with, at the end, us changing, and changing is nothing but learning. So how do we actually learn? So the brain learns in two ways. So the first way is we learn short term. This is knowledge, okay? So knowledge means this is biochemical. It is by using electricity and neurotransmitters. We get different forms of the brain to form neural networks. And then there's a very important organ in the brain, the so-called hippocampus. And the hippocampus is in charge of taking short-term memory into long-term memory. Then there's also something else, which is the so-called long-term learning, saying to learn a new motoric skill. A motoric skill would be, for example, to dance tango argentino. Whoever has tried tango argentino knows this is a real challenge because it needs two to tango, and you have only two shoes, right? Each. So neuroplasticity plays an important role. So you need to create situations where there's a high degree of neuroplasticity in the brain, and this can actually be influenced. Another element is neurogenesis. So neuroplasticity means the brain is able to form new neural networks to store knowledge, whilst neurogenesis is actually something very, very cool and it is not very old knowledge, that even the adult brain can produce new neurons. So the former belief was that when we are born with 100 billion of neural cells, and from then on we die from a brain perspective, right? Because all of that degrades until we eventually pass away. It is not like that. Actually, it's quite the opposite. We actually build new brain cells throughout our lives, but it depends on the usage of our brain. What is really, really interesting in terms of long-term learning is struggle. So the more you struggle with something, the more you wrestle with something, the more it is actually helpful for learning. So the cool thing about the brain is that it actually changes by the way we use it. So what fosters learning? So first of all, we have the foundational drivers. So neuroscience is pretty much in agreement that there's 4 foundational drivers that foster learning. One is exercise. The other one is sleep. The third one is nutrition. And the fourth one is meditation. These are 4 factors that are proven to work. Doesn't mean that they're not factor 5 or 6. So it is also shown that sufficient sleep allows for the brain to consolidate the long-term memory. So this is actually one of the 3 things why we sleep. So we don't sleep to relax our muscles. We sleep for 3 reasons. One is to process the day. This is the dreaming. The second one is the brain is an organ, and as an organ it has metabolic end products. So we need to get this out. And the third one is to consolidate memory and get short-term memory into long-term memory. So going back, so change and disruption. If we want acceptance and learning, we need to do 2 things. The one thing is we need to look at the neurobiological needs. So these are the 6 or the 3 dichotomies. And we need to look at the foundational drivers in order to get that. So this is something to look for. And then acceptance and learning is possible. If that is ignored, it will just prolongate the entire situation. If you want to read more, there's books out there, Neural Leadership, Resilient Leadership. You have my email address there. If you want the presentation, because I've seen you take pictures, I can send it to you. And with that, thank you very much for your attention.